Good morning, everyone. I welcome you to yet another session of the Knowledge Sharing Initiative and meeting today. I'm Goslav Adam Duncan. Before we commence today's meeting, I would like Emmanuel Isifi to give us a word of prayer.
Hello, good morning, everyone. Shall we pray? Heavenly Father, we thank you for this day. We thank you for bringing us together once again. We commit this program into your care, this knowledge sharing moment into your care. We pray that you lead us through this phase successfully, that will share knowledge to the maximum. This and many more we ask through Jesus Christ, our Son. Amen.
Thank you, Emmanuel. Please, I would like to find out if you can hear me before we proceed.
Yes, please, we can.
Thank you very much. So, welcome once again, everyone. Today's knowledge sharing is on the topic enhancing construction quality, the crucial role of engineering materials laboratory and quality control testing. And this will be presented by Emmanuel Atia. And before he starts his presentation, I would like to introduce him to the team. So Emmanuel Atia acquired his first degree in civil engineering in 2019, and currently he is pursuing a postgraduate degree in road and transportation engineering from the KNUST, or Kwame Nkrumah University of Science and Technology. Emmanuel was employed as an assistant civil engineer and road and transportation engineer in 2022. He has worked on, since joining the firm, he has worked on the OPRC project package 1 and package 3, that is both in Yendi and in Acherugu, since joining the firm. He is part of the transportation unit, a unit of 4 members, of which I'm the unit head. So without taking much more time, I would like to invite Emmanuel Atia to take over. Hello, Emmanuel. Hello, Emmanuel. Do you have
Hello?
Emmanuel on the line, please? Okay, Emmanuel, please, you can take it away.
Okay. Good morning, everyone. I'm Emmanuel Atia, and then today I will be presenting on enhancing construction quality, the crucial role of engineering, materials laboratory, and quality control testing. Please, I ask for some few seconds to share my screen. It's not allowed. Hello?
Hello, Emmanuel. We can hear
Yes,
you.
please, can you see my slides, please?
Yes, we can see it.
All right. So as I said, I'm Emmanuel Atia, and today's time of knowledge sharing, I want to look at the crucial role of engineering materials laboratory
Hello,
and
Emmanuel.
quality. Yes.
Please, can you put it in a presentation mode?
Oh, okay. So are you fine now, please? Hello?
Yes, Emmanuel. Yes, thank you.
Is it good now? Okay, thank you. So we'll be looking at construction quality, and then the role of the materials laboratory, and then the kind of tests we do. So in the next few minutes, the outline of presentation will be introduction, a few words about quality control. Then we look at safety precautions in the laboratory, as much as we want to control what is on site, or we want to achieve some level of quality on site. Our own safety is also very necessary. Then we will also be looking at quality control in road construction, where we look at the kind of materials we control, then some examples of tests that we run in the lab to make sure that everything being going on site attain a level of quality. Then we conclude with a few words, and then we look at the references there where all these data have been gathered. So look, introduction. Materials are the fundamental entities of every structure constructed on site. So anything we see on site, be it covered, we have been talking about concrete pipes, we have been talking about the layer GWC, we have been talking about a lot of things that we see on site. So anything we see that constitutes a structure or a component of the road construction, then it means that what it is being gotten from materials. This therefore in principle suggests that if a material fails, you can be sure, rest assured that anything that you are constructing on site will not last. So therefore the responsibility of the lab to test and analyze material and be sure that only standard material or correct or qualified materials are used at every stage in the construction process according to laid down procedures and then standards. So quality control simply means ensuring compliance with minimum standards of materials and workmanship to achieve the design performance of the road or the facility, but road in our case. So it is therefore measures put in place to eliminate the risk of non-conforming outcomes. So if you don't want your road to fail, then you have to control, in our case, the materials. So if you don't want your cover to fail, you have to control the concrete that has been used on it. If you don't want the road to fail in less than the years that it was designed for, it means that you have to control every material that goes into it, and this makes the role of the materials laboratory very crucial, very crucial. So quickly, let's look at some safety precautions in the laboratory. As I said earlier on, whilst we are trying to control quality on site, it means if you are not healthy or if you are not fully fine, you may not be able to take good control of things or of materials in the site. So first of all, you have to control, as we are talking of control, you have to control your own safety in the lab to remain sane, to remain healthy, to perform your duties well. So as much as we want to achieve quality, your own quality, let's put it in the quality in code, which talk of your health here, your hands, your eyes, your legs, everything. You wouldn't want to come to the lab in trying to make sure that the construction is done according to measures and procedures, but at the end you came with 10 fingers, then you are going back with 7 fingers. It wouldn't be fine. Or you come and then through that you inhale, and then at the end you are sick. First of all, you have to make sure, prioritize your health so that you'll be able to function well. So these are some few things, not limited to this, but a few things that you wear to protect yourself. Looking at this is a lab attendant in package 3 here. So we looking at him, he has his nose mask on, he has his gloves, he has lab hood, and then his safety boot in it. So this is the typical dressing of a lab attendant. At each test, you may require or you may not be required to use some of them, like the gloves like this. Some tests you may not be able to perform if you are using it. So the lab coat to produce or protect your skin from accidents, then lab protective gloves to guide against burns, and then all that. We have ovens in the lab. So in the lab too, we deal with heat. So if you don't wear gloves, you may end up burning your hands. So foot safety boot, as we all know, when we come to site, we try as much as possible to wear safety boot, not only in the field or on site, but also in the lab. And then there are some kind of machines that can produce deafening noise or deafening sound, such that you don't even need an equipment to measure the decibel before you say it has bypassed or it has passed the level of noise that a human ear should be subjected to. So when working with these machines, you have to use protective ear protecting or hearing protection. Then we also have dust masks or nose masks. Some soils, you work with them, you dry it, and then as you work with it, the dust generated is not good for your health. So you have to, these are a few things that you have to protect yourself depending on the kind of test you do to be able to remain relevant and do your work as a quality control personnel. So we now look at quality control in road construction. So when we talk of quality control, we can have a variety of things that you do to ensure that there's proper use of materials or there's proper execution of works in regard to materials to make sure that your construction is excellent and then well qualified. So we can talk of control of materials, where you look at the materials and then you look at the test procedure. Every material requires a certain test for you to give it an approval to be used on the road. And that test requires certain procedure that you have to go through. So you also look at control the test procedure, how you do it, how you run the test. Then you look at the frequency and extent of testing, the frequency. So maybe looking at gravel, or you look at chippings that we use for concrete. Standards have been given for you when and how to do the test. So when you do the test, or at what amount of material after being used are you required to do another test? And some to the frequency, then some material can lie down for a lot of time, and where you doubt its quality, you may require to do a test again to see whether it is qualified or not. And then you also look at equipment type. There are various types of equipment and its calibration. I think those who were fortunate to begin the time when they were about to start this project, they brought a lot of equipment, and then they go through each and every one of the equipment. Those equipment were calibrated to function very well. But with that, after some time, after you have used your equipment for some time, you have to calibrate it again, such that it will not give you a reading of 10 instead of 8 to affect your values. Then proper recording of your results is also necessary in road construction. So tests might be performed on individual materials. How do we what do we control during road construction? First of all, tests can be performed on individual materials. So you can control individual materials. Tests are there that will be performed to control individual materials like soil, gravel, aggregates, or binder, or something we basically call quota or something. So it can be an individual material. You have to also control mixes, gradation of aggregates. Something maybe you have combined there is not a single type of aggregate, but there are a lot of different sizes or of different shapes that you have to control, mixed proportions, mixed designs. So where they have concrete, for example, has a lot of entities, components. We have water, we have the sun, we have the to ensure construction quality. Then you can also, during construction process, you can also control spreading. Maybe those who have been able to go to package 1, the spreading of chippings after they have put the binder on the root, the spreading of chippings is there. Looking at the amount that are supposed to be put on the root, at what levels or at what rate or at what speed should the vehicle move, such that once the chippings come out of the vehicle on the roots, being spread on the root, it will be according to what is designed. Then we also look at controlling temperature, the mixing temperature. What is the temperature, for example, the binder or the coater? What temperature is it? We have standards that are used to control all this. Then spraying, at what rate? Sometimes we go to the road, then we see bleeding such that you see that, let me put it basically, the coater is too much or the binder is too much on the road, such that when your car passes on it, it can stick on the tires. So if you have to control the spraying to ensure quality, then we can also have tests that can be done on compacted layer, maybe density, GWC, or the laying of, we all know borrow pit, the material that they bring to the root, they lay to a certain thickness and compact. What test can you perform on it? It is what density. You can have a test on density. So we look at individual materials, we look at mixes, then we look at control during construction process. Then we also look at after construction, the laid or the compacted layer can also be tested. So tests for quality control. These are some of the few tests that can be performed on materials on site or in the lab. These are not exhaustive. These are just a few of the things I have taken for the purpose of this presentation. So we have gravel, we can do sieve analysis test, proto compaction test, Atterberg limit test, California bearing ratio. As also with the aggregates, we have this kind of test you can do, then the layer fill density test to see whether it has qualified or not. So as we go through, we will be looking at a few of them and then the equipment being used. So looking at sieve analysis test, the standard that we use to control proper use of materials on site gives us values. So when we talk of standards here, mostly our standards or what we use to control works or materials on site is basically values. They are half limits. They are standard, maybe let's say 1 to 2 or 2 to 3 and all those things. So we have standards. In the case of sieve analysis, it is done to determine the particle size distribution of the material. So when you are going to use it for a certain material, you have a standard for it to pass or for you to use it at this stage or for this purpose. You have a standard that is being used for the gradation or for the sieve analysis. So you use the sieves, the equipment, we use sieves for those processes to perform that test. We have the sieves that we are seeing in the picture. We have the one with the largest size or the largest aperture at the top, and then the one with the lowest at the bottom. So you put your material in the upper one, then beside it is the shaker. Using this one, you'll be able to shake it, and then you calculate with standards to see the gradation, how distributed are the materials that you want to use, and you compare with whatever purpose to agree or approve or disagree or disapprove the material for use to control your quality. So mostly for the next test that we'll be doing, what we know is that we use standards, and basically they are values. So you do the test, compare with the values or the standards, If it is not qualified, you reject the material. Or if it is not qualified, you look at a different way to solve it, to control your construction on site. So next test is proto-compaction test. So this is done to determine optimal moisture content and maximum dry density of the material. We all know that when we talk of moisture content, we are looking at the amount of water in the soil or in the material, in the gravel. So the borrow pit, using borrow pit, for example, when you bring it to site, there's a certain level of water that you have to put in the soil so that you'll be able to compact it to a very dense state. So the proto-compaction test with calculation will help you determine what amount of water should I add on these materials such that I'll be able to compact it very well. So some materials needs very little water, whilst some needs very large or amount of water. So when you do this test, you can tell control on site for this material, or even you take material from this side, add more water so that you compact it well, or add little water so that you can compact it well. And then you look at how dense, what is the maximum density that is possible to obtain in the lab, so that you can use it during your field density test to control whether they have compacted it well or not. So the machine here, we have a mechanical one that you can use for compaction. This one helps you to compact your material in different amount of water, after which you'll be able to determine the optimum one, the one that will give you the best performance or the best density. So this one, where this is from package 1 at lot 1, sorry. But in package 3 here, where you don't have this machine, you have to compact the material manually. Then we also have the California bearing ratio. So this also determines the strength characteristics of the material. So this is just an extended test on the compaction. So after you got your amount of water that you need to make a better compaction on site, then you proceed to look at the strength after you have compacted it. California bearing ratio gives you a clue about the strength. So depending on the kind of material you are using, it has a certain strength, minimum strength that it has to meet. So maybe let's say a certain strength, we want a certain strength, say 40. So you use this machine, the California bearing ratio machine, to perform your test and then calculate your strength. So if you're looking for strength 40, then it means that your material that you are doing, you should get the minimum strength to be 40. So after going through this test, you are trying to get the strength. So if you're looking for strength 40, you have to get 40 and above. And if it is less than 40, then you will not be able to use that material. Then we also look at Atterbeck limits test. So this one determines the liquid limit, plastic limit, and plasticity index. These are all standards in the specifications that we are using. So the liquid limit just talks of the amount of water that you add. This one, you have to use the fine part of the material, borrow pit material. To determine the liquid limit is you use the Casagrande. So it tells us the amount of water that we can add to the fines or to the soil, such that it will just begin to flow as a liquid. And then the plastic limit are also there. And then with the help of the liquid limit and plastic limit, you'll be able to calculate your plasticity index and compare it with standards. You'll be able to know whether or not the material is good to be used on the road. So we also look at flakiness. So this one measures the strength of aggregates, or chippings, the aggregates that we use in concrete, or let's say basically the stones that we use in concrete. So this gives you an understanding using this flakiness gauge. Also, the standards are there after you have gone through your test, then you compare to see whether to approve or disapprove. So with the flakiness gauge, you try according to the standard to see whether the material will be able to pass through this apertures or not. So when the materials are flaky, after which you determine whether it's flaky or not. So if it passes to be used on the root, it's not flaky. But if it doesn't pass, then you say that it's flaky. And flaky materials are not strong and not durable, so that you can use it on the root. So this flakiness test used to determine the strength of the material or the shape and size of the material. We also have elongation, which goes with the flakiness test. Looking at the size, or let's say how long the material is, how long is each particle of aggregate that you are using, how long it is. You do that, also get your values and compare with standards to know whether to approve it or not. And we also have Los Angeles abrasion test. So that one is done to determine the strength of the materials. Also, you are looking at durability or hardness of the material, the ability of the material to resist load or crashing and all that. So this is the LAA machine, or if you want, Los Angeles abrasion machine. This is the machine with the balls here. You put the material in the machine and then put the balls in it. After a number of revolutions, you will be able to calculate the wear on the material and compare your standards to control the use of aggregates on site. Then we also have compressive strength tests. So this tests the performance characteristics of a mixture. So let's take concrete, for example. So if they are they are producing casting concrete on site, you take samples with the help of moles. You take samples and for their specified days, like 7 days and then 28 days, you crash the samples using this one. So if they are, let's say they are constructing U-drains, for example, so they have started constructing, then you take samples during as they have started constructing. After 7 days, you crash it. You have a certain percentage, say 60%. By 7 days time, the concrete will achieve a certain level of strength. So 60%, you have your target strength that you are looking for. So let's say you are looking for a strength 25 Newton per millimeter square. Then you are crashing it to check whether you are getting the required strength or not. If you are getting the required strength, or if it is more than the required strength, very good, they can continue with what they are doing. But if you are getting lesser than what is required, then you have to prompt them. Maybe you have to go and see what they are doing wrong and correct them, so that you bring them back to the right process. Then we also have field density tests that we do on a compacted layer. A test that we do on a compacted layer. So maybe they have laid a sub base or a base, and you want to see, have the roller passed on the layer enough? Maybe the roller has passed on it 5 times, the roller has passed on it 6 times. So you want to check, has it passed on it enough? Have we achieved our maximum strength as we did in the lab? So you compare the results that you have here with that which is achievable in the lab to see the relative compaction achieved in the field. So you also have standards depending on the layer that you are doing or you are constructing. Some of them, maybe you may have to achieve a certain level, say 93%. Some you may have to achieve 95%. Some you may have to achieve 98% as what you got from the lab. If you get lesser according to the layer that you are doing, then you have to tell the ruler to pass through again. You have to compact again. Or if maybe, like we checked earlier, the water, maybe the water that you added wasn't enough, then you have to add water again and compact very well until we are able to get a good relative compaction before you can say that the layer has been compacted well. So this is a test, or the equipment you are seeing here, just a few. As we can see, he's digging. This is a destructive way of checking the relative compaction, the compaction on the layer. Destructive in the sense that you are spoiling or you are taking part of the compacted layer, which might not be able to compact very well after you have finished the test. But we also have nuclear densimeter gauge, where you can put the technology has advanced such that you can put this one on the layer. It can measure the amount of water in the layer. It can measure the compaction in the layer. Then after which you can proceed to get your relative compaction to know whether or not the compaction was enough. So in conclusion, we need adequate equipment and then adequately trained staff and on-job training that will work collectively to ensure a proper quality control and enhance construction quality. So if in all this that we have spoken about, which is just a section of things done in the lab to control quality on site, you need adequate equipment. If you don't have adequate equipment, all this we have spoken of, we would not be able to achieve them. You also need adequately trained staff. Maybe your staff may be trained, but they are not enough. Some of the tests, like the field density test, one person cannot perform it. So if you don't have enough staff to perform it, it may be impossible for you to control works on site. So if I give an example, if you go to Yendu, package 1, both lot 1 and 2, they have a lot of, although they may also be lacking, but they have a good number of staff or workers that are always on the road performing densities to know whether this has passed or not. It was the compaction okay or not, so that they will lay the next layer on the previous layer. But if you come to lot package 3, for example, there's a kind of suffering we go through here. So sometimes you don't even have the equipment, the density that you are supposed to, the relative density that you are supposed to even be able to calculate it on site and tell whether they should compact again or not. They don't have something we call speedy to calculate that. They have to bring the material back to the lab to do all those things. And by the time you go back, they might have done the next layer, and you can't. It's which makes it very, very difficult. So these are just the things that happen, and then the challenges. There are challenges that are associated with quality control. Like we said, adequate equipment is needed. Where there's no adequate equipment, like package 3, for example, it makes it very difficult to control quality. And then you can even talk of vehicle. There are no vehicle. Maybe you are ready to go and check quality on the site, but there are no vehicle for you to move. It makes it very difficult to control the quality. You wouldn't be able to achieve at that level of construction quality that you are hoping to achieve. And then you can also talk of on-job training. So as time goes on, new technologies are coming. Like we said, the nuclear densimeter gauge. If you include that into our works, it will make our work faster. It will make quality control faster and precise, although we can't comment on its accuracy now. But if you have the nuclear gauge, the nuclear density gauge, you'll be able to work for a long stretch within a few time, making you very efficient and then very, very reliable. You'll be able to control quality very well on site. So looking at all these things, if you have adequate equipment and adequate trained staff and good on-job training, be sure, or with good quality control, there are a lot of benefits that you'll be able to get. You can talk of less cost says that you'll not be going up and down. It will reduce your time that you go back to during the construction process. You'll be able to achieve or do the thing in the right way, such that you not go back several times, delay your progress. And then you also have at the end of it, or when they are to appraise your results, or when they are to appraise your works, it wouldn't be a problem at all. So these are some of the references used for the presentation. On this note, these are what I have for knowledge sharing this morning. Thank you.
Thank you very much, Emmanuel. This was a very interesting session, and I hope it was very helpful and insightful to the rest of the team, as well as it was to myself. Please, at this juncture, if you have any contribution or any question, you can please ask, or you can also type your question in the chat session so that we read it out for you.
Good morning.
Good morning.
Please, I'm Isaac Aqua. Please, I thank Emmanuel for a good presentation. My question is, he said in conducting a test for a material, if the material fails, there are different other ways of solving for the failed material. So I want him to give us the other ways of solving for the failed materials, other way materials. Thank you.
Yeah, thank you very much. Emmanuel, please, did you get the question?
Yes, please.
Or if you want
Yes.
to go, okay. So please, you can answer the question if you.
Okay. All right. Thank you, Isaac, for your question. So, like I mentioned, if a material fails, it is not every material that fails. I didn't mean every material that fails, you have a way to solve it. Some you have to reject it outrightly. But in the interest of the contractor, whilst they are trying, let's say you are looking for a certain strength required to get, but you are not getting that. You may have to do some kind of mixes, depending also still within the standards that you are giving or the specification that you are giving. You can try to blend two materials to see whether you'll be able to get the required strength or not. If you are still not getting, then you can just reject the material. But it is some of the tests that I'm referring to that you can, there may be different way to get what you want, but some of the materials or material tests outrightly you reject it. Thank you.
Thank you, Emmanuel. Isaac, please, has the question been answered?
Yes, please.
Thank you. Engineer Melanie, please, you can ask the question.
Okay, thank you very much. Good morning, everyone. Emmanuel, thank you for your presentation. Just a quick one. From Isaac's input, and generally through the presentation, we've been using the expression field, material field, or test field. It's just to say that we cannot say that it has failed. In engineering communication, we cannot say it has failed because every material is usable, except that it may not be suitable for the purpose you desire. So when the material is not suitable for your purpose, then it means that it did not meet your standard and specification, not all specification. I'm emphasizing these articles and all primarily because it could meet the standard for use if it's a material, but it may not meet what specific to your project. Am I communicating well?
Yes, sir. Yes, sir.
It's just a piece of information to clarify our use of the terminology. So if we say it has failed, it may not come. It may not be a good description of the situation that we have, because then that supports Emmanuel's point of view that when materials become unsuitable, there may be ways of improving on them. So we are improving on them to meet the standard and specification for the project. Sometimes the standard may just be all you have. There may be no further specification to it, or that you will have standard and specification. I'm emphasizing this because standards typically belong to the body of documentations that are basic to the practice. So everywhere they are accepted general codes. Specification may vary to a project or environment or condition of construction. So the condition of my use of concrete, which is a product, not a material, in construction when it is sunny will be different from my specification when it is raining. Because when it is raining, there is already high humidity and there's water in the environment. So I will design or I will carry out my mixing proportions of my concrete to compensate or take into account the prevailing environment, or as may be specified. However, on a usual day, it just needs to meet the standard design parameters for my project or the specification for the particular activity I'm carrying out. Okay, thank you. It's just so this is how typically you would find very great head engineers speak. They will insist that we use the trade language of our trade, and it is intended to confound those who do not belong to us. Okay, all right. Thank you very much. Please carry on. You did great, Emmanuel.
So thank you very much. Thank you very much. So from the chat section, I have Jacqueline's input here. He says, "Thank you, Emmanuel, for the wonderful presentation. I really enjoyed your presentation. In reference to testing, you bring up the topic of standards. Could you please clarify which regulatory standards you are referring to and who oversees the establishment of these standards? Additionally, it would be helpful to understand the significance and importance of these standards." So it seems we have about 3 questions in one as a bundle. So Emmanuel, would you like to address the question?
Okay, let me say something after which our bosses in the house can also add. So when we say standards, every country in the execution of works has their own standards or specification or their standards for work and these standards are supposed to meet looking at their climate and then their natural, their atmosphere, the ground, the kind of land they have there and all that. So every standard, every country has the way they do things, what they consider standard, and then all these ones were things that was put in order by engineers and then people of that country, or perhaps others coming in to help them. So when I say standards, that's what I was referring to. So some of the standards, like I said, we have surface dressing manual where you can use it to check in Ghana, made 2005, where you can use it to check the chippings that they are going to put on the road. There are some kind of tests that you are supposed to do on them, and then there are standards or values that you are supposed to compare with, that you will be able to tell, like Sir have said, whether the material is suitable or not. And then you also have standard specification for road and bridges, which takes into account maybe when you are looking at, that's from Ghana to July 2007. When you are looking at, let's say, an example, a borrow pit, you want to use material from a borrow pit. the kind of test that you are supposed to do on it. It tells you the kind of test you are supposed to do of it, for it, and then goes further to give you the limit where your values should fall according to your specific purpose, as say has put it. So all these are standards, and then point in time or standard methods of tests, like standard methods of tests for soil and then gravel used in pavement works like this. It's from GHA. All these standards I know, they are from Ghana Highway Authority. They have all these standards for execution of their works in the country. So anywhere you go in the country, in Ghana, you have standards that you are supposed to use in execution of your work. This the little I have, and then I think if others, like we have a lot of experienced engineers that can add their voice. This what I have. I don't know whether I have been able to help some.
Thank you, Ma. So yes, Mr. Komina, did you want to make an input?
Yes, please.
Okay.
Good morning.
Good morning.
Okay, when it comes to road in Ghana, the specification that you use is the standard specification for road and build bridges. That's from the Ministry of Road and Transportation. But aside from that, every project has a special specification. So even though you use the standard specification, but every project, most of the projects has a special specification. So if there is any contrary view on the standard and the specification and the special specification, we stick to the special specification because that specification is basically designed for that project. Thank you.
Thank you very much, Joseph. So that answers the topic about the regulatory standards that we are referring to, and then who oversees them. So the overall umbrella of all this is the Ministry of Roads and Highways, or the Ministry of Roads and Transportation. And then under that we have the Ghana Highway Authority, who also generally oversee all of these certifications. But we also have the role of the Department of Urban Roads, the Department of Feeder Roads also. So all of these agencies are important in when it comes to the regulation of the practices of road construction. Jacqueline was also asking about the significance and importance of these standards. I believe that without standards, we would have a big challenge, because what will be our reference? What will be what we go back to say that, okay, looking at this is okay? Will it be based on individual perception or discretion? So the standards look at the best practices, and then the procedures, and then the materials that we can use to be able to get the best output of the construction. So it defines for us what is acceptable and what is not acceptable. So for example, you cannot just go and pick any sand and say, I'm using it to construct a road. You cannot just go and carry, for example, a very clayey material for road construction, because we are also aware that there are situations of swelling, expansion, and then the suitability of that material for that project is what the standards deals with, to ensure that whatever material is being used for that project is of the best quality. So for example, if you are going to buy a shoe, there are some things that you are looking out for to make sure that when you buy that shoe, to be able to last as long as you want it to last, and also to be able to perform the functions that you are buying it for. So in the same way, the standards serve as a police or it helps us to identify whether the project what we are constructing is being done in the proper way, to be able to perform its functions and also last as long as we need it to last. That's when we come to the life cycle of the project. Jacqueline, please, does this help you in any way, or you need more clarification? Okay, thank you, Jacqueline. Please, if there's any more inputs from anyone, we can share. If there are also any more questions, you can please ask. Okay, so it's either we've succeeded in confusing you or we've succeeded in explaining it very well. But if you have any concerns or any contributions or questions, you can please ask. Okay, Emmanuel, if you want to ask a question.
Good morning once again. And I say thank you for a wonderful presentation. So I'd like to find out the schedule for recalibration of equipment in the laboratory. Thank you.
Emmanuel, so he's asking how frequent the calibration should be done.
Yearly, please.
Yearly. Thank you very much. But okay, so for some other equipments too, usually it depends on the frequency of use and then the type of test that it is being used for. So for some of them, it might not necessarily be yearly. It might have to be calibrated more often than the yearly. So it depends on the type of equipment. However, the usual practice is to calibrate them yearly or annually. Thank you. Please, Iman, does that answer your question?
Yeah, I think so. So another question. I think I heard somewhere, I read from somewhere about optimizing results in the laboratory. So I'd like to know whether you can speak to that effect. How we can optimize our results in the laboratory.
Come again, please.
I said, I think I chanced on it somewhere, optimizing results in the laboratory. So I don't know whether you can speak to that effect.
No, we don't optimize results here. So I can't speak to that. I can speak to that. I don't know. Can you say something brief about?
Okay, so maybe when I go further, so for instance, you are doing sieve analysis test, right? So you can perform some Excel functions to determine the sieve. Come again.
Okay. So you are talking about optimization.
Yeah, in that direction.
All right. So like I earlier mentioned, where you can combine materials to get your desired results or your desired strength. That is optimization. If you have let's say two weaker materials that you can do some kind of combination to get your desired strength, that is optimization. Or maybe you have a very good material and you have a very poor material, but you don't want to throw away the poor one to reduce your cost. Then you can do some kind of combination and do your test in the lab to be able to know what kind of proportion should I mix to be able to achieve a certain standard or a certain strength. Yes, so I thought you were talking of the recording of values. Thank you.
Thank you very much. Please, any more contributions or questions? Okay. Thank you very much, Emmanuel, for a nice presentation. And thank you everyone for making time to participate in this knowledge sharing session. We hope that you took the best from this presentation and also added to your knowledge. Thank you very much for joining. I hope to see you in our next session. Thank you very much.